Okay, new semester, welcome. Okay, we're going to start with chapter 6. Chapter 6 talks about polygons. Okay, remember we introduced polygons last semester and we talked about what a polygon is. Okay, multi-sided, multi-angled figure. We specifically look at convex polygons, the ones in where each vertex points away from the center. Okay, and we looked at two basic types. Okay, what's called a regular polygon, one where each of the angles has the same measure and each of the sides has the same length. I want you to think about an equilateral triangle. All three sides are equal in length. Each of the angles is 60 degrees. Think about a square. Each of the four sides has the same length. Each of the angles are 90 degrees. Those are examples of regular polygons. Okay? So, angles of a polygon, we're going to talk about that first. Names and classifications is part of it. We're going to talk about what a diagonal is. Okay? Most of you understand the concept, but it's important when we talk about polygons. Interior and exterior angles. We broached that subject with triangles where we had the exterior angle theorem. Okay? Where the exterior angle is supplementary to the angle adjacent to it, but equal to the two that are added together that aren't adjacent to it. Okay? Same with exteriors. The resources you've got here. Number one, I've included my chapter 6 notes. The first 4 pages are what we're talking about today. Okay? And also the PowerPoint that's chapter 6, section 1. You should look at those. They're going to help you. Okay? The ones that we're going to look at are basically these. And you need to know the names, not because in a quiz or a test it's like, how many sides in a pentagon? Rather, they are going to be the words in the problem, and you need to know how many sides are in it so you can solve the problem correctly. Okay? So 3-sided we know is a triangle. 4 is a quadrilateral. Okay? Okay. The prefix on the word is going to give it away. Quad, 4, tri, 3. Pentagon, penta's 5. Okay? Hexagon. Okay? If you've ever worked with tools and nuts and bolts, hex nut has a 6-sided nut. Heptagon, I have also seen septagon used here. Okay, I think our book uses heptagon. Octagon, 8 sides. Octopus, 8 legs. Okay, decagon, 10 sides. Deca, decade, 10 years. Okay, and n-gon. N is just for all of the others that there's no name for. Okay, you'll see in a second on the examples. Okay, now, when we talk about the sum of the interior angles, there's a formula, okay? N represents the number of sides, and n minus 2 times 180 gives you the sum of the interior angles. Let's think about why this works, okay? We all know that the sum of the interior angles in a triangle is 180. It's important, okay? What this does is, let me just take a 4-sided figure, okay? If I take that 4-sided figure and I draw in a diagonal, how many triangles are there? So, 4 sides, 4 minus 2 is 2 times 180. So what this formula does is count the number of triangles for you. Okay, if you think about it, 5-sided, okay, 5 minus 2 is 3. When you draw the diagonals, it creates 3 triangles. Kind of cool. Okay? Now, the next thing here is if it is a regular polygon, and you're asked to find the measure of one angle. Take the sum and divide by the number of angles. All you're doing is adding that to the equation, nothing more. okay? So if you have the sum, let's go back to our equilateral triangle, okay? 3 sides. 3 minus 2 is 1. 1 times 180 is 180. So 180 divided by 3 gives you the 60-degree angles all the way around. Let's think square. 4 minus 2 is 2. 2 times 180 is 360. 360 divided by 4, 90-degree angles. It works like that for all regular polygons. Okay? The other important aspect of this here is the sum of the exterior angles. The sum of the exterior angles of any polygon, any, is 360, always. Only answer, no work, the sum of the exterior angles, one angle at each vertex, is 360. Okay? Now, let's look back to our regular polygon. What if the polygon is regular and we need to find the measure of one exterior angle? Okay? Divided by the number of angles. Okay? So, back to our equilateral triangle. Okay? 3 sides. So, 360 divided by 3. Each of the exterior angles is 120. Does that check out? Is it supplementary to 60? 120 plus 60 is 180. Let's think about a square. Okay? 360 divided by 4 is 90. So the interior angle and the exterior angle are equal, which makes sense because the sides are perpendicular. And we know that perpendicular lines form right angles are equal. That's how this works, folks. Okay? Let's go to examples. Not a ton, and I think you're going to find these problems to be pretty easy, and definitely the assignments will be easy. Okay? Here we go. Find the sum of the interior angles of each convex polygon. Okay? They will make sure you know it's convex so we don't have to do any crazy stuff. Boy, that glare is bad, huh? Okay? There's what the question looks like. Wow, I just saw that bright white spot on the camera here. Okay, here we go. So, interior angles. How many sides in an octagon? Well, we know there's 8. So, okay, there we go. Okay, now we've got an 11-gon. That's where the n is. The n is the placeholder for 11. So, 11 is our n. That's it. Okay, that's what we're dealing with. Okay? Now, we'll take it a step further. The measure of an interior angle. So what we're given the answer now. So we're going to work backwards. Okay? So the measure of an interior angle is given. Find the number of sides. So in this one, we're going to find n. Okay? Start with your equation and work from there. Okay? So this is what it's going to look like, okay? Remember we said if we want the individual, we've got to divide it again. So we're given the individual, so this is how we represent it. Clear the n by multiplying both sides. I'm also going to distribute here. Okay? So what I've done is just multiply everything through. Okay? Okay? Add the 360 to both sides, subtract the 144 from both sides. Okay? There's your answer. You're done. Okay. Same thing with 160. Set it up and do the same thing. Distribute, multiply up. Okay? Let's see, colors we've used. Okay. Now, we come to a problem that says, find the measure of each interior angle. Okay? They're represented with variables. What do we know? Well, 4 sides, so, okay, n minus 2 times 180. 4 minus 2 times 180, 360. These 4 angles have to add up to 360. There are the 4 angles added up to 360. Okay? Combine similar terms. Okay? 2, 3, boom, boom. Add up the x's, combine the numbers, subtract, divide. So the x is 50. Now we go back and substitute it in because it wants the actual measure. 2 times 50 is 100 plus 15. 50 plus 15. 150 minus 20. And that's how you do that type of problem. Find what the sum is. Use the sum to solve the problem. Okay? Our last series of problems here. Find the measure of an exterior angle and an interior angle given the number of sides. Okay. We have 16-sided figure. Okay. Let's do the easy one first. The measure of an exterior angle, 360 divided by 16. Okay? 360 divided by 24. 360 divided by 30. That's what we're dealing with. Okay? That goes in, yeah, check my own work. Okay? No, they're always not going to come out pretty. You're going to get decibels sometimes, or fractions. Okay, so those are your exterior angles. Now, for the interior angles, yes, we can go back and use this formula that we just did, okay? But I can also give you a shortcut. So we're going to do one, okay? We're going to do this one right here, just to go through that particular thought process, let's say. Okay, let's use that, okay? Okay, we're just going to substitute in and work through. Okay. Um, 10, 15. Okay. So, once I found that 24 minus 2 is 22, 22 over 24, yes, I simplified right away. Then I've got 12 and 180. I simplified that. So now all I have left is 15 times 11. Now, let me show you the really cool shortcut. Every time you have an interior and an exterior angle, you're forming a linear pair, which means they have to be supplementary. Those two together have to add up to 180 degrees. That's how it's going to be easy for you, okay? If I subtract 22 from 180, if I subtract 12 from 180, okay? Make sure okay? That's what you're dealing with. Okay? That is what we're going to look at for polygons. Okay? Very good. Enjoy.